In the previous video, we were looking at breaking up a fairly large fraction into simpler terms. This one is just a sort of a secondary example. First, always check to see if these are of the format where your your denominator's derivative is the numerator. If it is, then it qualifies for an antiderivative of natural logarithm. We don't have that. Our denominator has a derivative of 2x, and clearly that's way more than 2x. So we use long division as a tactic to break a big fraction down into smaller ones. Specifically, your denominator is the divisor, x squared minus 7. Now notice that we're missing the linear term, so I put in a 0x as a placeholder. The numerator is the dividend. It's not missing any powers of x, so I just put all four terms underneath the division bracket, and then we can proceed. Like in the last video, for long division, to get it going, you take the first term underneath, divided by the first term outside. X cubed divided by x squared is x. Then you take x times all of the divisor. X times x squared is x cubed. 0x times x is 0x squared. Really, it's just for a placeholder, so your like terms will stack. Negative 7 times x. Change all your signs. Vertically combine like terms. X cubed minus x cubed is 0. If that first column goes to 0, you're doing it right. That's always a good check moment. Negative 4 minus 0, that's 4x squared. Excuse me. Negative 4 minus 0, that's negative 4x squared. Negative 6x plus 7x is 1x. And then bring down your next term. Starting the process over, negative 4x squared divided by x squared is negative 4. Negative 4 times the divisor is 4x squared, negative 4x squared plus 0x plus 28, and that again is negative 4 times all three of these terms. Change all your signs. Vertically, you have like terms. Negative 4 plus 4 is 0. That tells us we're on the right track. 1 minus 0 is still 1 for the x term, 1x. 28 minus 28 is 0. So this one, this big fraction in the original problem can be rewritten as x minus 4 plus x over x squared minus 7 plus x over x squared minus 7. It's quotient plus remainder over divisor. That's how you translate that out. This fraction and in the parentheses are the same. Taking the antiderivative of the first two terms, that's x squared over 2, which is 1/2 x squared. Negative 4 has an antiderivative of negative 4x. And then I'm going to leave this third term, x over x squared minus 7, and an integral of its own. So the first two, you have the antiderivative, but I held off on this one. The reason being is x squared minus 7 has a derivative of 2x. At the moment, we only have 1x up there. But remember, if all you need is a number, you can multiply in the missing number and then rebalance it out front. Half times 2 is still 1. So now we have the denominator's derivative as the numerator. So these two terms still come down, and then we have plus 1/2 times a natural log of the absolute value of our denominator plus our constant of integration. In the next example we switched to a definite integral. The integral from 0 to 3 of 7 over 2x plus 1 dx. This parenthetical phrase around to 3 decimal places, I put that in there because your WebAssign account This type of problem, some of them they do ask you to approximate instead of giving the exact value. I'll go over that at the end of this problem. Specifically, let's pull this 7 out of here. And the reason being is our denominator, 2x plus 1, its derivative is 2. So that 7 is really just a distraction. We can't lose it because it's part of the original problem. But I'm going to pull that 7 out to the front. And then we have the integral from 0 to 3 of 1 over 2x plus 1. The derivative of 2x plus 1 is 2. So this is a case of where there was originally a 1 up there, but 1 is not the derivative of the denominator. So I needed to put a 2 here, and you can. If it's only a number, you can multiply it in. Just remember to rebalance it with a 1/2. So we have 7/2 out front. The antiderivative of this fraction, because now we've established the derivative over the original, we can go natural log absolute value of 2x plus 1. And then it's a definite integral, so we're going to evaluate at 3 and then 0, and subtract halfway through. We have 7/2. Natural log of 2 times 3 plus 1 minus natural log of 2 times 0 plus 1. So our top number goes in first, our bottom number goes in second. In the bracket, or excuse me, not bracket, the absolute value, we have natural log of 7. In the second absolute value, we have a 1. Recall from algebra that natural log of 1 is 0, so that actually just is a term that goes to 0, leaving us 7/2 times natural log of 7. That's the exact answer. If you type this in your calculator, you get 6.811, and that's rounded to 3 decimal places. This is the one WebAssign will be looking for because it asks you to approximate. This would be your answer if it didn't ask for an approximation and it wanted the exact. That's the difference. Our last example, we have the integral from 1 to e of 1 plus natural log x to the 4th power over x dx. This one, we can use a substitution method. If we let 1 plus ln of x equal our substitution, and we can call it u, then our derivative is du equals 1 over x dx. This constant 1 has a derivative of 0. So all we need to keep track of is du equals 1 over x dx. Notice that the rest of the integral is 1 over x dx. Therefore, we have the integral from 1 to e. Now, in order to help you see it a little easier, I left this 1 plus ln of x to the 4th. I left it alone, and I just scooted this x over. It's still in the denominator, but it's easier to see this fraction if you split it this way, because once you take your derivative of your substitution, 1 over x dx is actually what you have to account for out here, and that's just du. Remember, if you substitute from one variable to another, and we went from x's to u's, you have to filter the upper and lower limits of your integral, putting e through the substitution. 1 plus ln of e is equal to 2. Natural log of e is 1, so 1 plus 1 is 2. That's our new upper number. The lower number 1, 1 plus ln of 1, that's 1 plus 0, which is 1. That's our new lower number. It actually didn't change, but you still have to filter it through the substitution to verify. Now, our antiderivative is u to the 5th over 5, which is 1/5 u to the 5th. Evaluated at 2 and 1, So we have 1/5 times 2 to the 5th minus 1 to the 5th. Well, that's 32 minus 1, which is 31, for a value of 31 over 5. I hope this video has helped you out. Reach out by phone or email if you need help. If you're on campus, swing by the office and I'll do my best to help you.